Hey, everybody, welcome back to the Particle Accelerator Podcast, where we talk to future thinking business leaders about how to grow their business and accelerate their team. I'm here today with Jonathan. Jonathan, will you please introduce yourself?
Hi, everyone. I'm John Teaford. I'm the CEO of Green Steel Environmental. We're a clean tech company that we've been running for the last 18 months.
Awesome, awesome. Tell me a little bit more about what they do.
Green Steel, we've licensed a number of technologies from the University of Colorado related to how our wastewater treatment plants remove excess nutrients out of the wastewater. Currently, wastewater plants use hazardous chemicals to pull things like phosphorus and sulfur out of their water stream and out of their gas stream. And we have a clean tech replacement for those hazardous chemicals. So we're replacing an input that wastewater treatment plants use today with a clean tech upcycled material.
That's cool. So, is that using like microbiology to do that, or how's that work?
It's actually not microbiology. No, it's a granulated additive. So the hazardous chemicals that are used today are typically iron-based chemicals. Things like ferric chloride is one of the hazardous chemicals that's used in the highest quantities. And a professor at the University of Colorado worked as a wastewater treatment plant process engineer early in his career, and he noticed that ferric chloride did a very good job at getting phosphorus out of wastewater. And if phosphorus is left in the wastewater, it causes toxic algae blooms downstream from the wastewater plant if there's too much phosphorus in the water. And later in his career, when he was in academia, that professor found a material called steel slag that is a byproduct from steel manufacturing. And that byproduct, steel slag, has a lot of iron in it. And so he thought, what happens if I experiment with this material and I grind it up and I put it in a wastewater treatment plant's digester? Can I replace those hazardous chemicals? And he found that you can. So he found that you can get all of the phosphorus and all of the sulfur out of a wastewater plant using this upcycled industrial byproduct and replace hazardous chemicals in the process.
And then that would be something that our body is totally naturally able to deal with, kind of thinking from the drinking water
Sure.
aspect of this. Yeah.
The water that comes out of the wastewater plant is not contaminated with those hazardous chemicals, right? The hazardous chemicals do a good job in small quantities, but when you start trying to get more and more phosphorus out, you start polluting the water that leaves the plant with the hazardous chemicals. And so in a lot of different parts of the country, they can't use those hazardous chemicals anymore. They're trying to move away from it. And the material we use, it's just a ground up bunch of rocks, right? So it floats around in the digester. It sequesters the phosphorus and sulfur, and it settles in with the biosolids at the plant. Very little of it goes out the door as water. So we basically use this industrial byproduct as a vehicle to get phosphorus out of wastewater, and then it goes into the biosolids, where, interestingly, in large parts of the country, those biosolids are used as fertilizer. So our material, we use this industrial byproduct and turn it into fertilizer at the end of the day.
Well, I'd love to get to know you better. This is going to be really cool to talk to you about this. As I was studying for mechanical engineering, I ended up joining the dark side and going computer science. But I'd love to get to know you. And one of the ways that I do that is asking, what was your first job? Like, how did you make your first buck? For me, it was a paper route. What was it for you?
So I was pulling weeds at an apartment complex. A friend and I worked all summer pulling weeds out of lawns and plantings, trimming bushes, working the landscape crew. And I can still remember the day I got my first check from the company and had all kinds of questions about the taxes that were being taken out of that check and how much was left over at the end of the day. But yeah, that was a great experience, working long, hot days in the sun.
Excellent. What toy or hobby did you have as a child that inspired what you do career-wise today?
As a kid, I did a lot of skiing. So my parents liked to ski, and I grew up in Philadelphia, and then we would head up to the mountains in Vermont or in the Pocono Mountains in Philadelphia, and we skied quite a bit. And as I moved out here to Colorado, and I live in Boulder, Colorado, which is a beautiful, beautiful part of the country, and I spend a lot of time skiing at resorts. I spend a lot of time skiing in the backcountry. My primary ski buddy has now become my co-founder at our company. So I think that's been a great boon for me. One of the things that's really interesting about skiing to me is that, skiing in resorts is great fun. I have a lot of great time, but skiing in the backcountry, when you get out into the mountains and you're moving through the mountains, it's just really spectacular. So it's been a constant stream of growth for me, learning more about how to recreate safely in the backcountry and how to get the most out of everything I do when I have free time on the weekends. And I think I've taken that into the business world as well, just looking for new ways to grow and expand.
Yeah, awesome. Yeah, that's really cool. What was your favorite and least favorite course in school?
Favorite course in school was called Financial Market Theory in my undergraduate work. Loved the process of learning how assets are valued, how option valuation models work, how the efficient market frontier works. That was just absolutely fascinating. It led me into a long career in finance, which led me to a position where I could finance and operate businesses. Least favorite class, I guess I took a class in literature, and we studied Chaucer. Canterbury Tales. And that was the most difficult class I ever took. And I would probably describe that as my least favorite class. I think it was the only literature class I took in college, and I just could not get through the material. It was so dense. It took me an enormous amount of effort to pour through it. When I opened up my financial market theory book, the knowledge just flowed into me. But when I opened up Chaucer written in Old English, boy, it seemed like it bounced right off.
Yeah, I was talking to my oldest son who's 22, wrapping up his undergrad, and we talked a lot about that. Like the things that you feel like you can immediately apply, that become a part of you as you're learning them, are so much easier than the things that you really just want them to be a stream of consciousness through the materials onto the test. And, he was expressing how he really didn't like it when there were topics that he couldn't internalize. And there are just some of those topics, calculus for me, definitely one of them. I love math, but when it came to calculus, I just want to know how to get the right answer. I don't care how you derived the formula, but if I can get the right answer, I'm good to move on. I don't really need to know exactly how it works.
Yeah. No, I understand that as well. And not just how it works, but how to do it without a calculator, right?
Right, exactly. Yeah, I don't need to go any extra, just whatever it takes to get the right score. Cool. Well, what quote from a famous person lives in your mind rent free?
I was reading the other day a piece on Tolstoy, and he wrote, "If you want to be happy, just be." That's bounced around with me for a long, long time. And I've thought about it a couple of different ways. I've thought about, does that mean for me that I can choose to be happy, that happiness is a choice, that I can approach the day from a happy perspective? Or does it mean that I'll be happy if I can live in the moment, if I can just be myself and just live here today and not be thinking about tomorrow and next week and my 5-year plan? It's led me down a couple of different paths, but if you want to be happy, just be.
I had a mentor that on one side of the screen, he wrote do, be, have. And on the other side of the screen, he wrote be, have, do. This was really transformative for me because the idea of use something like success, like, okay, I can do the thing, I need to do some stuff so that I can be successful, so eventually I can have success, right? And it's like this mindset of chasing success is what this doing, like, I got to do all these things, I got to do as much as I can in order to have success, and then eventually be successful or have the perspective that I'm successful. But if I were to be successful right now or have the mindset that I'm in this state of being of success, just as one example, then I would naturally do the things. I could actually have success today, and then I would, by very nature, do the things that successful people do. And this really messed me up because I was such a doer, and just how much stuff can you do before you kind of fizzle out? But just realizing that some things we want to have, we can just decide to be right now.
Absolutely.
A lot of freedom in that.
Absolutely. Yeah. I also like to think about living my life from a position of abundance. I try to approach every day thinking about how much I have and how full I am and how much abundance of life and of opportunity I have in front of me. Living from a position of abundance is a terrific way to brighten things.
As an antithesis to scarcity, if I feel like money is scarce, then I will hoard it. Then in hoarding it, I don't invest it, I don't give it, I'm not generous. The scarcity mindset generates more scarcity, whereas the abundance mindset generates growth. 100% agree.
Absolutely.
Cool. What do you think the greatest invention or discovery was in the past 300 years?
I guess I would say we'll see where AI takes us, but that might be on the list, right? Ask me 10 years from now. The greatest invention in the last 300 years, that we do talk a lot about wastewater treatment plants, and a wastewater treatment plant operator will tell you that an organized system of collecting and processing wastewater is the only thing that stands between us and a third of us dying from the bubonic plague. That's what happened way back when. So I might put a vote up for a system of organized wastewater collection and treatment.
Yeah, for sure. Yeah, big deal. Awesome. Well, we'll get into the main round topics here. So what tech trend significantly impacted your industry, and how did your company respond? Obviously, you already discussed using the flag steel, if I said that properly, to filter the water. Are there any other tech trends that have significantly impacted your industry and that you guys have responded to?
There's a really interesting one happening right now. Our customers are typically wastewater treatment plants, and those are very complicated places, right? Inside a wastewater treatment plant, there's a lot of biology, there's a lot of physics, there's a lot of chemistry. The pH matters, the temperature matters, and there are, as many as 20 or 30 different steps in the process, the flow of material through a wastewater treatment plant. And so in the past, when a wastewater treatment plant wanted to see, what would happen if I made a change to the way we operate, or what would happen if I had a change in the inputs that come into the plant every day, they'd have to just experiment. They'd have to try something new and see what the result was. But the recent trend is a trend to develop what they call digital twins. This is a digital representation of the plant. And it takes data, because plants produce lots of data on measurements of nutrients, measurements of chemicals, measurements of flow rates. There's a huge number of data points that a plant collects every day. And this digital twin takes all of those inputs over, a 20 or 30 year period of time, however much data they've got, and teaches a model what's going to happen tomorrow. Right. So given a set of inputs into the plant, what's going to happen tomorrow? And they can do that now in this digital twin environment, which lets them experiment. Right. It lets them cut costs because they can plan how much chemical they have to add or how much time they have to spend treating material in a better way. It lets them experiment with new materials. So from our case, we're working to get our product embedded into digital twin models so that plant managers can see what happens if I switched to the green steel environmental product, and they'd be able to see that ripple through the rest of their operations. It's a long process to get a model built. Wastewater treatment plants are not known as a hotbed for digital development, but we met with one plant recently that spent a year building out the first phase of their digital twin. So this was the learning phase, just teaching the model how things operate and getting all the data into the model. After that, they'll move into a projection phase where they can start to project what's going to happen tomorrow based on a series of inputs today. And then the final phase, which they're not sure they're ever going to do, is to let the digital twin run the plant to some extent. To forecast, because we forecast this tomorrow, we're going to make this change in our operations today. There's a little bit of consternation about whether that should be allowed to happen or how much freedom a computer model should be able to have in operating the plant. There's some cybersecurity issues associated with that. There's some operational issues associated with that. There's regulatory issues. There's, health and the environment issues. But wastewater plants are doing a lot. Municipalities are doing a lot to figure that out and to figure out how much they can do with a digital twin.
Yeah. In that autopilot state, what would be really interesting is what are the prime directives, because obviously you could go so extreme on one counterbalance that it would solve all the problems. You could pump a ton of chemicals into it and have no issues, but you can drink the water. So it'd be interesting what the control group is there, because in aviation, I was always kind of dumbfounded to think that there was a minimum equipment list. There was things that can be wrong with the plane that are okay to be wrong, and we can still fly passengers around. And I think the layperson would probably be horrified if they knew what that toleration was, that level of tolerating that, yeah, certain things aren't perfect, but we're going to keep going. And we'll fix those on the next maintenance cycle. And I would imagine in water treatment, there's a lot of things that could be not quite right that are still good enough. And I think autopilot model would have problems with that.
Yeah, that's definitely something to think about. You can't take it back once it's out, right? Once the water flows out of the plant, you can't go grab it again. It's in the stream or the lake. Here in our town in Boulder, in the wintertime, our wastewater treatment plant releases, clean treated wastewater into our nearby creek, and it doubles the flow rate of that creek in the wintertime. In the summer, it's a much smaller percentage of the flow rate. But this is really important to get right. It's got to be right. It's got to be right all the time, because the consequences are pretty huge, right?
When I was in college, I was in Omaha for a bit. I would go to church in Council Bluffs. We had a guy there that was a chemical engineer, and he worked at the water treatment plant. And he came in, one Sunday pretty frazzled. You could just tell he hadn't slept much that week. How'd your week go? Awful. And he was like, we could not get it right. This was just one of those weeks that we couldn't get it right. The microbes were going crazy. It was just all over the place. Come to find out, it was Iowa's maple tapping season. And 2 miles upstream from the water treatment plant, there was a maple grove, and they had tapped their maple trees and not managed the runoff. And so there was maple syrup essentially oozing into the source water, raising the level of sugar and completely overpopulating the microbe. They couldn't control microbial growth. It took them forever to figure out the source. And then, of course, they went up there and negotiated with the landowner to do something about that and got the problem at least, temporarily resolved. But one of my favorite stories, I've known about that for 20 plus years. And it's wow, this is how much we depend on science, right? For our daily lives. You just don't know what you don't know. The common person would have no idea that there was literally warfare going on inside this water treatment plant, and that like lives were being saved over how they handled this emergency.
Sure. Yeah. I mean, they grow bacteria and then they feed the bacteria the material that we send down to the plant, right? And the bacteria consumes it, turns it into gas at some point. Basically the digester's purpose is to take solid material and turn it into gas, or as much of it as you can. And they can get a 40 or 50% reduction in the volume of the solids material that they have to process just by turning it into gas. I'll say two things about that. Number one, the people that work at wastewater treatment plants are frigging brilliant, right? These are folks that have master's degrees in engineering or PhDs, and those folks are rampant at a plant. When you talk to a wastewater treatment plant manager about the very point that you just brought up, right, trying to figure out what's going on in the plant, there are so many inputs. There's so much happening. There's so much physics and biology and chemistry at work. You've got to have really, really smart people doing it. And they are absolutely brilliant people that run these plants.
That's so cool. Well, what are three other technology innovations you're betting on to drive your business growth?
Yeah, so we licensed these patents from the University of Colorado, right? And that's been a fascinating process. The state universities in Colorado spend $1.3 billion a year on grant-funded research, and that all generates intellectual property, right? And that intellectual property, much of it is there available for people, for entrepreneurs, for people like me to license and take forward. If you look at the kind of a company that would generate $1.3 billion in research and development, that's like Boston Scientific spends $1.3 billion on R&D, right? Except that this is not owned by a company. This is owned by the state university, right? And it's there. The University of Colorado welcomes entrepreneurs to come in and look at their patent portfolio and tell them whether there's something that they think looks commercializable. And that's what I did. Every April, the University of Colorado brings in 150 entrepreneurs, shows them a package of patents that they think are the most ready for the market. And you pick one and build a pitch deck around it. I did that about a year and a half ago, and we won that process. They picked 10 companies to move forward. We got a stipend, a 6-month salaried part-time position at the university to start our business as an entrepreneur in residence at the university. And then at the end of it, the technology looked like it was going to work. You can stand up your own business. So that's what we did. So we have licensed the technology from CU, and we're very close to landing our first commercial customer out of it. That's been a remarkable process. There were 3 technologies that we licensed. The first we thought was ready to go today. We were excited about that one. And we learned very quickly that it was not ready. And that technology was an improvement to the way that we make sewer pipes. So it used steel slag, the same material that we use in wastewater treatment. But if you put steel slag and some other materials together in concrete, it makes the concrete sewer pipe antimicrobial, and so it lasts longer. You can make you can have a sewer pipe last 3 times as long. And that's a big deal because sewer pipes are a big pain in the butt to dig up out of the ground and close the street and, replace it all. And there's, how many millions of miles of sewer pipes there are in the US. But when we got closer to that material, the lab results looked great. Right? The work in the lab was perfect. The patent was great. It looked like it was ready to go. And then we learned that our next step was to put this material in the ground and test it for a year. And for an entrepreneur to wait a year before you find out that you can move forward was just a daunting thing.
Yeah.
So we decided, we couldn't build a business that involved waiting a year for results. And so we looked at the next patent on the list that we'd licensed, and that was the patent that we're moving forward right now. So we still have this concrete product and we're still moving that forward, but it's not going to be the first thing that we take to market. We've got a third patent that's really interesting. I mentioned the gas that comes out of a wastewater treatment plant. As they convert the solid material, part of it gets converted into gas. That gas is mostly methane. It's about 60% methane, but there's also hydrogen sulfide in there, which contaminates the gas. And methane, that's natural gas. That's what natural gas is. So wastewater treatment plants are a source of renewable natural gas. They produce natural gas every day. And if they scrub out that sulfur from the hydrogen sulfide, what's left is pipeline quality gas. They can sell it to a pipeline operator, or they can consume it locally for energy. And there's all kinds of federal and state stimulus to get people to do that, to create more renewable natural gas at their wastewater treatment plants. And so our second product uses steel slag to scrub that sulfur out of the biogas. So we scrub sulfur and siloxanes, or another chemical that we can get, and volatile organic compounds. Those are 3 contaminants that have to be removed out of biogas before it can be sold or consumed. And so that'll be our next product. And that's the one where we're spending the most time and effort to make right. That's a big market, and we're excited about that. The lab results that we took over from the professor show showed that it worked, absolutely works, and that it's not effective enough to compete with products that are used today. And so that's our big research push now, is to show that our material, to improve the efficiency with which it removes sulfur so that we can replace the existing, non-renewable, expensive materials that are used today to get sulfur out of biogas.
That's really cool. So what are some of those gaps between those ambitions to become more efficient than the non-renewable methods?
It's just a process of experimentation, right? So we've got a brilliant team at the university who's, parts their lives into this product and into this science. And so it's talking to them about, what do we think would work? What do we want to try next? How do we alter the size of the granules that we use? How do we alter the way they're distributed through the column? How do we alter the way the gas flows through or across it? How do we change the contact time, the amount of time the gas has with it? There are 7 or 8 different variables that we can try. How do we process the material differently, right? We can separate different parts of our material out. What are the parts of the material that are really scrubbing the impurities out of the gas? The siloxanes are a chemical that are in a lot of self-care products. So shampoos and creams and conditioners and the like. The wastewater, they go into the plant, they get converted into gas. And if they stay in the gas, they foul the engines that are running on the natural gas. Or if you're using it in your home, it would foul the burner on your stove. And so getting siloxanes out is a thorny thing. And so we've gotten a lot of interest from customers on how our material works for siloxane removal. We noticed that one of the great takeaways from starting this business has been just paying attention to customers, right? When they perk up and they express interest, right, that leads us to where we need to go next. And when we talk about siloxane removal, customers say, tell me more about that. So
Yeah.
that's where we're going.
That's cool. Is there ever any variable around like charging the slag, like electromagnetic charging, or is there things that happen there I'm just thinking of the vibration of the slag, or tell me more there. If I'm just having a hunch, I don't know if it's backed, but do you experiment with that?
Sure. So we have experimented with using magnetism, or the magnetism of the iron component of the slag, as a way to potentially remove the slag from the biosolids. So, can we get the slag out of the material at the end of the day? And so, yeah, we have looked at that, and we're continuing to look at it. We haven't figured out a use for that yet, but it's pretty cool stuff.
Yeah, I remember in grade school, the big thing was, this food has more iron in it. So the biology teacher at school, he created a centrifuge, just a magnetic centrifuge in the bottom of a beaker, poured some, Wheaties, or, your basic cornflakes that say they have more iron, they're iron fortified, pours it in there. And then he like holds up the magnet that's got now a bunch of metal flakes attached to the magnet after spinning the cereal. And he goes, yeah, this is the iron they're talking about. They're putting earth metal in the cereal to say that it has more iron, but your body doesn't digest this. It's not the mineral iron. It's just iron. And I always thought that was great to learn. I was probably in grade school or something. So yeah, that's what brought that to my mind. Not really anything grounded in science.
That's a pretty cool grade school experiment.
Yeah, it was really cool. They did a whole series of he had a little bit of like weird science tricks. And that was the one that like, okay, so at a young age, I realized I couldn't really believe in any kind of advertising, that like the advertising slogans were.
On that point for 1 second, we work in a business to business environment, and we market business to business. When you start a company and this is a new product, no one's ever sold this product before, right? I had not sold things to wastewater treatment plants before I started this business. But when we think about that marketing message, or when we look at our marketing message, customers have different reactions to different messaging. And when we try something and it works, like we found a couple of marketing messages that cause customers to just stop us and say, wait a minute, tell me more about that, right? I mentioned the siloxane removal earlier, right?
Yeah.
We noticed that, and so we leaned into it. We've noticed another couple of really interesting ways that we talk about our material and things that we talk about that cause customers to say, wait a minute, go back to that. I want to hear more about that. And so that's become the tip of our spear. Paying attention to how customers respond to your marketing messages, is we've learned so much about what their problems really are based on how they respond when we talk to them.
Yeah, I mean, that seems like how you're going to maintain a competitive edge, not only having good metrics on those things, but knowing what they are, like knowing what those hooks are. It'd be hard for somebody else to step in. Are there any other ways that you're planning to maintain a competitive edge?
It's all about talking to customers and learning what their problems are, right? Because they're not immediately apparent to us. And sometimes I'm not sure that the customers even really understand the problem, or they don't understand what a solution to the problem might be. Talking to them, walking their plant, talking to them about each segment and how it works. We've learned a lot because our customers are not just municipalities. We're talking to customers that operate food production facilities, produce a lot of wastewater and have to treat their own wastewater, right? We're talking to livestock farms. There's a lot of wastewater produced at dairy farms in particular, and we're talking to them about how they treat that water and how they get their phosphorus out. And listening to those customers about what their problems are is just eye-opening. And we've developed what we think might be some really interesting approaches to the market. Not just right now we sell a material that replaces a current input that they already use, but we've thought of some ways that we might be able to upend the whole market. Like, how do we do this differently? How do we do it in a way that nobody else could? At some point, we may find a way to revolutionize the way that nutrients are moved out of wastewater treatment plants. We're not quite there yet, but we keep listening to customers. We might just find it.
Yeah, and what a great problem. I mean, it's super important. Like, purifying water is never going to go away if you can do it better, cheaper, faster. But then how do you mitigate risk and manage risk when you're implementing a cutting edge technology?
In the municipal world, that's 100% of the game, is how do we show them that we've mitigated the risk? Number one, we've got indisputable data from a very highly regarded source. So the university and the professor in particular that we're working with, they're both very well known. They've done great work for a very long time, and they're trusted sources of data. And so the original data that we started with is very highly regarded. And so that's been a big, big step forward for us. The next step is to do more testing. So we've spent the last 9 months testing steel slag in wastewater treatment plants in every way that we can think of it. And we test phosphorus and sulfur, and we test pH, and we test it for its suitability for application as fertilizer. Does it meet EPA regulations? And they're all different kinds of steel slag, and we've tested all of them. Is it appropriate to be put into a landfill? Right? There are rules for what you can put into a conventional landfill. If you don't meet those rules, then you have to go into a hazmat landfill, and that would be terrible and expensive. So, we know an enormous amount about our material and about how it works at a wastewater treatment plant so that we can tell a plant operator, look, this is exactly what's going to happen. Here's what's going to happen downstream in your plant. Here's what's going to happen when it leaves your plant and it goes into the environment. All of that is really, really important. And we've got to have unassailable data to prove that it's going to work.
Yeah, this is so interesting. So combining that with the digital twin, do you feel like all water treatment plants have the digital twin, or do you think many of them are trying to create it?
No, it's very new. In fact, the folks I spoke with most recently said they haven't heard of a wastewater plant anywhere in the country that has fully implemented a digital twin. It's just at the outset right now. There's a lot of work left to be done, but I think when it gets there, it'll be a really, really valuable tool for them.
Yeah, I can imagine that. And then the data sharing, had another guest who's really talking about like data sets and different reactions to different microbes and these data sets, different experiments that were run. This idea of sharing data sets within a company, we really silo our data and we think of it as an asset for us that maybe we'll use someday. And I really think these data marketplaces, we've had data marketplaces in commerce around like spending habits of people. And I have an online advertising background. And so for years, there's been this massive sharing of commercial data, so much so that we've gotten really interested in privacy lately. But the ideas that they've pioneered through some of that sharing of data and having data marketplaces, I think are really missing from kind of the industrial space or the environmental space, because we're all investing in research, but yet we're hoarding our data. And so where can we go to kind of share this data and this research at a level that would be beneficial to models? So working with a couple of clients that think that they have some ideas in that space, but I think that's going to be a really popular thing, is this notion of sharing data and all the attributes associated with different element models.
Sure, yeah, every water or wastewater treatment plant is a custom designed facility. They're all different, right? They've got different equipment, different processes. Generally, they're similar sort of themes, like the way they put it in place and the way they operate it. It's custom every time it's built. It's not immediately obvious how you could use data from one plant to inform another. Mm-hmm. But when you look at it on a big scale, if you were to get every wastewater treatment plant's data all in one place, you could learn so much about how to operate more efficiently, about how to take cost out of the system, and about how to design the system better and more efficiently. These are expensive places. Salt Lake City's building a new wastewater treatment plant. It's going to cost over $100 million to build a wastewater treatment plant.
Wow.
Yeah, I mean, and that's all public money, right? This is not something we want to spend. So yeah, finding a way to share data across different locations is going to be a big part of how you make it valuable.
Yeah, great. Well, you sound like an amazing CEO and business leader, from how you love financial modeling class to just the things we're hearing you talk about, how you run your business, how you talk to customers. How do you approach setting up your technology roadmap? You even mentioned some hurdles that we're not brewing whiskey or wine here, so we can't wait a year to get a positive result. So you've pivoted. You must have some insight in how do you do your annual planning?
One of the important things that I think about when we describe the direction for our research, it's become an important part of the roadmap for defining what our company is. There's an old saying, if you want to know what your values are, look at your budget, right? Where do we spend our treasure? Those are the things that you really value. And so when we think about our technology roadmap, that needs to be absolutely in line with the direction that the company is going and with the way that we define ourselves. And so the types of projects that we undertake have got to be consistent with that. Right. We are an environmental, clean tech environmental company. We use upcycled materials to replace legacy products that are either too expensive or bad for the environment. Those are the kinds of problems that we try to solve. And so when I show a new employee our technology roadmap as part of our onboarding process, it's got to be consistent with that message. We're an early stage company, right? We're pre-revenue. So we also have to get it right. We can't take too many swings at the fence that don't connect. Right. So it's got to be on message, it's got to be on point, and it becomes a part of our culture. The technology roadmap is an important map that describes and defines the culture that we're building.
I love that. So you're going back to vision-driven roadmap, values-driven. And I love your vision, by the way. I mean, who would not be on board if you're an engineer, a chemical engineer, mechanical engineer, doing the things that you do? Who could not get on board with, hey, we're going to take things that otherwise would be thrown away and we're going to turn them into something that's super needed and required in keeping people alive with clean and water. I mean, that is a vision that you can quickly attach to. And then, yeah, it must make a lot of sense when you see, hey, and these are the 5 to 10 objectives we have for the year. These are our rocks, to use the EOS term. Do you use any well-known methodology as you do that planning? Have you been influenced by OKRs or EOS or any of those business management frameworks, or are you kind of rolling your own?
We've been doing it on our own. And so, we picked up a series of patents. Interestingly, along the way, we saw an experiment up on the wall in the professor's lab, and we asked, what's that? He described it to us, and we said, well, do you have a patent on that yet? And he said, no, I haven't. And we said, well, if you can get us a patent on that, we can win you a grant to finish the rest of the research and turn it into a product. And so within 2 weeks, the university had a patent, a provisional patent application filed and out the door. And then 3 weeks after that, we won a grant to help bring it to life. The one thing I haven't talked about are the amazing role that grants can play for companies that are commercializing university research. I mean, before we were 6 months old, we'd won almost $400,000 of grant funding to help us productize these technologies that we had picked up. And that's non-dilutive financing, right? Those are grants from either the state. There are also very large sources of federal grants for early stage companies. But that's how we got our first step out the door. And that's what's led us to where we are now on the cusp of putting the product into market.
That's so cool. So cool. And I love doing this podcast because I get exposure to these kinds of things. And you're really giving people an amazing model for a successful business. Go check in with your local state school, see what kind of research they're doing, see what kind of patents they're getting. Maybe this is unique to Colorado, but maybe not, right? You could have somebody right down the street from you that's inventing things but doesn't have the ability, just isn't aligned with moving those things forward as commercial products. You can get grant funding to go further those ideas. I mean, that seems to be a wonderful working model rather than a bright idea and go get a bunch of VCs. And by the time you're 3 rounds in, you have no equity left over. And I'm seeing that a lot in the market. So that's quite awesome. I guess the way I would love to pick your brain more as a business leader, how do you handle initiatives that failed to deliver expected value? Have you learned any lessons from failure?
If you want to make a big impact, you do have to swing the bat. You have to step up to the plate and you have to try, right? And you got to take a big cut at the ball. And sometimes those things don't work out. And so we've had lines of research that have led us, down paths that we thought looked promising initially. But when you get it further and further out of the laboratory, things can start to change, right? We've had lab results that looked awesome. And when we got it out into the real world, it just looked different. And I think from an entrepreneur's perspective, there's 2 things there. One is the cost. What does it cost you in money? And the bigger bigger one for me is time. How much time did we just lose because we spent 3 or 4 months working a product down a path that did not work out? And when I look back, how do I feel about having spent the money and having spent the time? It's spending the time that hits me the hardest, right? I can raise more money, but I can't go get more time back. Thankfully, those have been somewhat few and far between for us, but they definitely happen, right? If you're not finding a dead end, maybe you're not trying hard enough, or in our case, we're not trying hard enough.
Yeah, and my experience with grants is that they kind of start small and you show something and then they get a little bigger and they are kind of evolutionary to try to reduce that risk. And very much so the same with VC funding, you're kind of trying to attach yourself with some folks and as it's growing, they're taking bigger bites of the apple. But are grants like that? Do they tend to kind of taper up as you're seeing positive signs of life?
In particular, one of the larger opportunities for early stage companies is a federal grant program called SBIR SIBR grants. And those start with a phase one that's a couple $100,000. And then phase two comes and that's maybe $750,000. And then you can go all the way to phase three where you might have a couple of $1 million to help you develop a product. So grants are structured often in very much the same way where you've got something that looks good, then the grant money comes in and helps you take it to the next level. You show those results. And if it's working the way you think it is, there's more money to follow.
So in that sense, like failure is kind of wired into the process. If you keep looking for positive ideas, you could reboot, but yeah, you can't get back the time.
100%. Yeah.
Really cool. The whole idea of the grants is really cool. And to see how you're building multiple product lines with that same idea. What advice would you give to somebody who's starting their journey?
When we started this business, every step forward was a little bit of a slog, right? It was, we got to move this forward. What are we going to do today? Like in the early stages, it feels a lot like we're pushing a ball up a hill. Like my co-founder and I've been blessed to have a great co-founder. He's really terrific. And the two of us together, we put our shoulder to the ball every morning and we try to push it a little bit further up that hill. And just in the last 3 or 4 weeks, I've started to feel the ball moving a little bit without having to push quite as hard. It's starting to roll a little bit, right? We're getting customers that say, wait a minute, you got to come to my location and show me how this works. Like, wait a minute, that's the problem I've got. Like, can you fix that problem? You've got to come show me. And so the ball is starting to roll on its own. And I would say that my advice would be you got to keep pushing that ball up the hill. It's hard and it's long and it's a slog, but once it starts to roll, it feels incredible. It's just remarkable when the market starts pulling and customers start telling you how great it is and revenue starts to become generated. That's a terrific feeling. I'd say keep pushing the ball.
The old golfer thing, like if you can just get one good swing in an 18-hole game, it'll bring you back to the course. Just one proper drive that'll keep you hooked. Yeah, momentum is a real thing. Like building up that momentum is a real deal.
Absolutely. It takes effort on product. It takes effort on market fit. It takes effort on marketing and talking to customers. As a founder, co-founder, you've got to do it all. Right? You've got to put on all those hats and you've got to drive them all forward at the same time.
Well, cool. If people like what you've had to share today, how would you like them to connect with you?
Our website is greensteelenvironmental.com. My email, info@greensteelenvironmental.com. And you can find me on LinkedIn, Jonathan Teaford.
Cool. We'll make sure to have those links in the show notes. Really appreciate the time today. And it was very interesting to hear about these environmental advancements. I wish you the best.
Thank you so much. I really appreciate it, Benjamin. It's been great talking to you.